Here's problem 517. 3 blocks shown are released from rest and are observed to move with accelerations that have a magnitude of 1.5 meters per second squared. What is the magnitude of the friction force on the block that slides horizontally? Disregard any pulley mass or friction in the pulley and let m equal 2 kilograms. Alright, so we got mass 1, which is 2 kilograms. We have mass 2, which is 2m, 4 kilograms. And we have mass 3, which is 2m, 4 kilograms. Now we basically have the 2 kilogram mass 1 balanced on the left hand side with the 4 kilogram mass 3, m3 balanced on the right hand side. So we have a pretty good idea that this whole system is going to move in a forward direction like this with one common value of acceleration. If we treat this like a blob, total mass of 10 kilograms, moving in that forward direction with one acceleration, we have a force at the front here equal to m3g, pulling it along. We've got a force at the back holding it up equal to m1g, and then there'll be a frictional force of contact of mass 2 with the surface here. That's actually going to equal mu m2g, but we just want to find that whole frictional force. So if I were to write Newton's second law, and also there will be a normal force here and a m2g here, but those are going to be transverse to the motion, not in the direction of acceleration. If I were to write Newton's second law for this motion, I would say the summation of all the forces is equal to the total mass, m1 plus m2 plus m3, times acceleration, and that is equal to the net force in the direction of acceleration. Acceleration being our positive direction. So our positive forces are going to be this m3g, and our other forces, our negative forces, are going to be this m1g and this frictional force. So we're going to write it like this: m3g minus m1g minus the force of friction at the between block 2 and the surface there. We want to solve this for the force of friction. That's what we were asked for. So we have 2 plus 4 times acceleration, which is 1.5, is equal to 4 times g minus 2 times g minus friction. Let's bring friction over to the left-hand side. So we have the force of friction is equal to 4g minus 2g is 2g, so we have 2 times 9.8 minus the total mass, 10 times 1.5. So we have 19.6 minus 15, or 4.6 newtons. So that is the frictional force of the surface on mass number 2 on the plane, the top plane. And it's a positive value, so we assume the correct direction of it against the motion as this whole system moves to the right. 4.6 newtons.